All right, here we are with video number 2 for the last half of the equations practice. We are still on solving exponentials. In number 13, you're looking at solving a base e exponential. No different. We want to make sure that we get the exponential by itself so that we can convert to a natural log and then solve for p in this case. So I'm going to add 3 to both sides first so I can isolate that exponential. That's going to give me e to the p minus 2 equals 76. Now, at this point, the base e is isolated. We're going to convert to natural log. So starting with the base. Now, the log that has a base of e is the natural log. It is not a log. So make sure when you're converting, it is into natural log, not into log. So it's going to be natural log base e of 76 equals p minus 2. Again, that's natural log of 76 equals p minus 2. Last step is to add 2 to both sides. And that gives me ln of 76 plus 2 equals p. Now in your calculator, you're going to put that in. And when you do, you get 6.331. Now there was a slight typo on the choices. The answer is B. That 0 right here is not necessary, but I think you can see which one you should have chose. Now for 14, we have a base 7 exponential. We cannot rewrite 18 as a base of 7, so we can't use that nice property. So we're just going to have to convert and solve. There's nothing I need to move, so I can go ahead and convert, starting with the base towards the equal sign. This is going to be log base 7 of 18 equals x plus 1. Again, so that's log base 7 of 18 equals x plus 1. Now, sorry, that writing is horrible. All right, with the log base 7 of 18, that is not a base 10 log, but you can use the change of base formula in your calculator to figure out what this number is. So remember, change of base formula, which I say it COB, it's easier to write. Change of base formula is going to tell us that we need to take log of 18 and divide it by log of 7. All right. And there should be an equal sign here that didn't carry over. And then at that point, we can move this 1 over to the left by subtracting. So I'm also going to subtract 1 from both sides. In addition to the log 18 divided by log 7, in order to evaluate the log base 7 of 18, I subtracted 1. And then when I put that into my calculator, I got that log base 7 of 18 minus 1 is 0.485, which is A. All right, we're moving into applications of logs and exponentials. So we're still sort of solving, but it's applying the context as well in terms of figuring out what you're solving for. So in 15 and 16, we are taking a multivariable equation and solving for one of the variables. In 15, we're solving for D. So basically, just as with any of these solving equations that we've done specifically with exponentials and logs, you always want to get either the exponential or the log isolated so you can solve for what you want. In this case, I have an exponential right here, and that exponential is where D is. So I need to get this by itself so that I can convert to a log in order to drop that exponent down and solve for D. Very first thing I want to do is to divide by 2 on both sides so that I can isolate that exponential. That's going to give me 2b. 4b divided by 2 is 2b equals a, can't see it, a to the 5cd. Now, in order to drop this down, I've got to put this base a exponential into log form. So starting with the base going towards the equal sign, I want it to be log base a of 2b equals 5cd. Again, that's log of a of 2b equals 5cd. Now the last step here, to solve for D is to divide both sides by 5C. So this is what D equals, which is C. Now number 16, similar concept. You've got, in this case though, it's a log equation, and you want to solve for R, which is inside the log. In order for me to get rid of the log so that I can solve for R, I've got to put this into an exponential, or put it in exponential form. So just as before, we want to isolate this log, which means I need to divide by S on both sides first. And it's going to start looking like a 5, but just remember it's an S. So that gives me log base 2 of 4R plus 1 equals 3T over S. All right, now, at this point I can convert. That'll get rid of the log and turn it into an exponential, starting with the base towards the equal sign. 2 raised to the 3T over S equals 4R plus 1. Again, that's 2 raised to the 3T over S equals 4R plus 1. 2 more steps to solve for R. First step is I've got to subtract 1 from both sides. So that's going to give me, excuse me, 2 to the 3T over S minus 1 equals 4R. And then the very last step is to divide both sides by 4. So once I did that, that gave me R. So this is the value of R, which is A. Now the last 3 questions deal with an application of growth and decay. So it's either interest, compounded, or compounded continuously, or it might be standard growth or decay. And number 17, we want to know how much money would you need to invest in order to have $15,000 saved in 2 years. So we already know the final value. What we don't know is the initial. We want it to have an interest rate of 6.3%, and it is compounded quarterly. So I know I'm using my compounding formula. So if I set that up, I know that my final value, which I want to be 15,000, equals some initial value that I'm solving for times 1 plus the ratio over n, the rate over n. The rate is 0.063 as a decimal over n. Since we are doing quarterly, n is going to be 4. So it's going to be 0.063 divided by 4, and that's going to be raised to the n times t. N is 4. T, it says 2 years, so 4 times 2. So I'm just going to go ahead and call that 8. All right. Now what I did for this one is I did all of this part in the calculator first. And I made sure when I did that I put this in parentheses so that it evaluated it correctly. When I did that, I then, since I'm solving for the initial value, whatever this is, when I put it in my calculator, I'm dividing both sides by that so that will get that initial value by itself. So when I take 15,000 and I divide it by the result of putting all of this in my calculator, I end up getting that the initial value is equal to $13,237.21. Now there obviously is a slight typo here. The answer should have been B. There was a typo. The 6.3 should be 3.7. I double checked it, so I apologize for that. I'm going to go ahead and I'm going to scratch this out, and I'm going to just replace it with the correct answer, which is $13,237.21. So basically we would have to invest $13,237.21 at a compounded quarterly interest rate of 6.3% in order for it to be worth $15,000 in 2 years. On number 18, you're looking at population in Tanzania in 1987. In 1987, it was 24.3 million. There was an annual growth rate of 3.5%. We are assuming that it's changing continuously. That's really important. It tells you the equation to use at this rate. What will it be in 2008? So if we are going from 1987 to 2008, that tells us our time. That tells us that our time has to be 21 years. 21 years passed between 1987 and 2008. And then, of course, our rate is 0.035. We just need to remember that since we're compounding continuously, we're going to use the PERT formula. So our final value equals the principal, which is our initial value, times e to the RT. All right, we are trying to find the final value. Our initial population was 24.3. Multiplying that by e raised to the 0.035 times 21. All right, if you put that in your calculator correctly, remember e is a number. It's above. To access it, you've got to click the button above click the function above the natural log button on your calculator. If you put that in your calculator correctly, you should get that the final value is 50.7 million, which is C. 19 is just a standard decay question. It says a computer's value declines. That's what tells me it's decay. It's going down 7% every year. So we're decreasing 7%. The initial value of the computer she bought is $800 in 2019. How much is it worth now? We're going to assume now is 2023. So if I'm going from 2019 to 2023, that must mean that T has to be 4. So if I set up my standard decay equation, which is final value equals initial value times your growth factor, or decay factor in this case, raised to the t. Remember, if we're declining 7%, we want to subtract 7% from 100%. The other way of saying that is I want to take 0.07 and subtract it from 1. So our initial value was 800. Our decay factor should be 1 minus 0.07, and thus raised to the t, we're saying t is 4. This is the same thing as saying 800 times 0.93 raised to the 4, and plugging that into your calculator, you end up getting $598.44, which is A. Last question deals with finding how long it will take for a $1,300 investment to double if it grows, again, continuously at a rate of 4.5% per year. So we're still using the PERT formula, or we're going to use the PERT formula. We want it to double. Now, I know it's 1,300. Double 1,300 is 2,600. So we want it to be 2,600 at some amount of time. When we invest an initial amount of 1,300 and we're multiplying that by e to the RT, our rate is 0.045, and we're solving for t. We're trying to figure out how long is it going to take us for this to happen. Now we're going to divide by 1,300 first. The interesting thing about these questions where you're talking about doubling, tripling, whatever, is it really doesn't matter what the money is. In this case, we're doubling, and if you notice, when we take 2,600 divided by 1,300, that gives me 2 equals e to the 0.045t. Well, it's 2 because we're doubling the money. So if we wanted to do the same thing and say how long does it take to triple it, it would be 3 equals e to the RT. Basically, the money cancels when you convert it, when you're using words like double, triple, quadruple, etc. So now all we've got to do is convert the base e to a natural log. Remember, if we can undo a base e by taking the natural log of it, and it'll drop down this exponent. If I want to take the natural log of the right, I need to do that to the left as well. So if I want to take the natural log of e to the 0.045t so that I can cancel out that e, then I've got to do the same thing on the left. So what you end up having is that the natural log of 2 equals, now remember, if I'm taking the natural log of e, Those are inverse operations. They cancel each other out. So on the right, it equals 0.045t. Last step is to divide both sides by 0.045. So that tells me that t must be 15.4 years, which is t.